Okay, so year 11, I'm just going back to the start here. So this is the investigation task that's coming up, and this is the information that you need to know. And it'll probably come through in class, but I'm going to have it in as a video as well. So in the task, you'll be looking at a range of functions, including straight lines, parabolas, circles, and hyperbolas. Okay, so your answers that you'll be looking at, and using the Desmos or some other graphing technology, you'll be asked to describe functions and include terms domain, range, the gradient, intercepts, turning point, asymptotes, axial symmetry, center, and radius. So just in case we haven't had these terms before, the domain and range, that'll be for all of the things, and the domain is the x values and the range is the y values that the function can have. And the way to easily remember it is that the letter D comes before the letter R, and the letter X comes before the letter Y. So D before R, X before Y. So domain is the X values, and range is the Y values. And when we look at some examples, you'll understand. Gradients only apply with straight lines. Intercepts could be for any of the functions. Turning points only to do with parabolas. Asymptotes with hyperbolas. Axial symmetry, parabolas. Center and radius are with circles. So I've got some examples, and I might need to add some things as we go along. Okay, so straight line, you're going to have a gradient. You may have x and y intercepts. Like for instance, if I've got a straight line, I'll just change colours over there. It has a gradient undefined. It has an x intercept, but it doesn't have a y intercept. Now if I change colours again, okay, another straight line. It has a gradient. It has a y intercept, but it doesn't have an x intercept. So it just depends. Parabolas, you'll have turning points, which is down here. You'll have an axial symmetry, which is an x equals something equation. You're going to have a y-intercept, and you may have x-intercepts. Okay, it just depends. You're always going to have a domain and range. Okay. Circles. So you're going to have a domain and range, and you may have x and y intercepts. Like for instance, the circle could be up there, which means it doesn't have any intercepts, but it'll have a center. Okay, so it'll have a center, and it'll have a radius that you'll have to describe. Okay, but it may or may not have x and y intercepts. The hyperbola, there's going to be a domain and range. The imaginary lines that the curve approaches, like for instance, if that was x equals 3, a function approaches 3 from both directions, but it doesn't actually get to 3. And we'll look at an example. So you've got a horizontal, okay, you've got a vertical asymptote, which is that line, which will be x equals. There's a horizontal asymptote, which the function approaches from above or below, which will be a y equals equation. In this particular case, it's sort of y equals 0. And it may or may not have x and y intercepts. So for instance, that one has a y intercept, but there's no x intercepts. Okay. So let's have a look at an example. Y equals 2x plus 1. It's a straight line. The highest power of x is a 1. So this is the x line, and the function can have any value of x anywhere along. So we say that all x, the domain is all x, and the range is going, change colours, the range is going up and down, and I can have positive x's, I can have y equals 0, I can have negative y. So say positive y's, 0 y, negative y's, so the range is all y. In this particular case, the gradient is 2, the y-intercept is 1, and I calculated the x-intercept by just putting y equals 0 and solving that. So that's all you can say for that one. When you have parabolas, the domain, okay, so x values, we can have negative x's, we can have 0, we can have positive. So the domain is all x, but the range, if you have a look, the y values only go from -3 upwards, so we say y has to be bigger than or equal to -3. There is an axial symmetry, which is x equals 1. There is a turning point, and the y-intercept would equal something there, will equal something, which you can calculate if you know what the equation is, and the x-intercept would equal something as well, which you can calculate, which would be those two values there. So you can have a y and x-intercept in this particular case. Okay, looking at a circle, the domain, the x values are only going from 0 to 4, so we say 0 less than equal to x less than equal to 4. The range is going from 2 to -2, so we say -2 less than equal to y less than equal to 2. The centre is 2, 0. The radius is 2, it's going 2 in every direction. In this particular case, the x-intercepts will be 0 and 4, and you could write that down as 0, 0, comma 4, 0. So you could write it as a coordinate. The y-intercept, there's only one y-intercept at 0, which would be just 0, 0. Okay. And looking at the next one, which is the hyperbola. So these ones look like fractions when you see them. You know, like for instance, y equals, 1 over x plus 1, something like that. Okay, so in the x direction, we can have any x except this value 1 because the curve can't get to 1, it approaches 1. So what we say is just all x except x equals 1. The range, which is going up and down, okay, so the curve's approaching 2 from above and below, but it can't get to 2, so we say all y except y equals 2, so those they have an exception to the case, and the vertical asymptote is the vertical line that the line approaches, so whatever you've got there, that's the equation, and whatever you've got there, that's the equation. In this particular case, the x-intercept would be that number, so it equals something, which we'll calculate later, and the y-intercept would equal that number, so it equals something. But we don't know until we have an equation. Okay, so that's it. So that'll give you an idea about what to expect for the assignment or the in-class task. Okay, thanks. Bye.